Thank you to all the sponsors. Thank you for everybody attending. Can everybody see my screen?
Yeah, it's up.
Yep, brilliant, cool. So yeah, fundamentals of the Lakehouse architecture with Synapse. I guess what we're going to be talking about here is an architectural approach, some of the gotchas, going through that. I would love it if everybody can, if you've got questions, put them in the chat. I'll get to them one way or the other. There's also some poll questions, so that's where I'm going to ask for a little bit of interactivity. Like, you're going to have to respond, and I can make a really awkward silence. So you're probably going to be better off responding sooner rather than later. A little bit about me. Yeah, I do now work in the Synapse Customer Success Engineering. You can follow me on whatever. These are, not necessarily the views of my employer, which is something that I have to say in case I say something bad. And then we're just going to, what are we going to talk about? So first of all, I just want to level set on what is Synapse Analytics and what are the parts, because we can talk about Synapse Analytics as being one thing, or we can talk about what are the actual component parts that are inside that. Second of all, I want to talk about what is the Lakehouse approach? What does the Lakehouse actually mean in reality? Then talk a little bit about Synapse Analytics in the Lakehouse. How and when does the Lakehouse work? And then sort of conclude with some tips and tricks. And if we've got time, depending on how I'm going for time, we might even talk about how Power BI works with the Lakehouse, because that's also a question that I often get asked, so I can kind of answer that in advance. So first question, and what I'll do for people who don't want to post into the chat is actually put into the chat something, and you can like it. You can give it a thumbs up, you can give it a whatever one makes sense. So let me just put those in for you. Oops, if I can spell. So you can also just like the chat messages that I put in, or you can, like Fernando, you can write a comment. A little, somewhat. A couple of people who don't know, a couple of people who are very familiar, becoming familiar with it. Hopefully that's a positive experience. It is great. That's excellent. Bit of hands-on experience. Awesome. All right. So we've got a bit of a mix of everybody. So I'm not gonna give everybody a, this is not a deep dive into Synapse Analytics, but that's good. And I think actually, because of the way this works, most people have actually probably responded with who's actually using it. So I won't go into the second poll. So what is Azure Synapse Analytics? If you've gone to a Microsoft marketing presentation or something, you might have seen a diagram that looks very similar to this. It's a unified experience. It brings all these things together. Rah, rah, rah. You've got data sources on one side. You've got other sources on the other side, where you might be publishing data into Power BI for reporting purposes, or you might be enriching data into other sources, sometimes also known as reverse ETL these days. I guess what Synapse Analytics is fundamentally is a unified experience that brings together a whole host of capabilities. So it brings together different runtime, analytical runtimes, whether that's SQL, Spark, Data Explorer, and that's built on top of a whole host of other technologies from the data lake perspective. I should make sure this is more up to date. And it also brings together some of our no ETL tools that allow you to bring data in. So using Synapse Link for Cosmos DB, for Dataverse, and for Azure SQL now. And so what you can kind of look at this is you start to pull this out to say, what is this? Let's move past the marketing. Let's get to something real. So you can quite clearly see that there's a data lake as part of that. So Azure Data Lake Storage Gen 2. There's Synapse SQL Dedicated, used to be called Azure SQL Data Warehouse. There's Synapse SQL Serverless, so the ability to write queries on top of the data lake directly and just have those queries look like SQL, smell like SQL, but actually it's just files coming from the data lake, and that's going to be something we're going to talk a fair bit about today. Synapse Pipelines, which is the experience that comes from Azure Data Factory, so Azure Data Factory native pipelines, where you can orchestrate different activities, copy data between on-premises data sources, cloud data sources, and orchestrate activities. We've also got Synapse Data Flows there. So Synapse Data Flows is also a technology that comes from Azure Data Factory, not from Power BI. Power BI has data flows. Azure Data Factory also has data flows because naming at Microsoft is a fun thing. And that is where you can have a low code, no code graphical interface that ultimately executes Spark code. So you can think about this as, the data flow component of SQL Server Integration Services, SSIS, for the cloud. The great thing about it being Spark oriented though, is that anybody who's tried to scale SSIS will generally know that that's not always a fun experience, but knowing that it's Spark under the covers gives you a lot of confidence in the scalability of the solution, but also in the behavior of the solution. We've also got Synapse Spark. So, you can write Spark in a low code, no code environment where you've got a graphical editor, but you can also just directly write Spark. And that obviously opens up writing Python, writing Scala, writing Spark SQL. We've then got Synapse Link, the technology from a no ETL ability to take data from Cosmos. I will come to that question in 1 second. Take data from sources like Cosmos DB, from Dataverse, and actually just materialize them into the data lake. And we've got Azure Data Explorer, which is a more recent component to the Synapse experience, and that's really for telemetry data, log data, very real-time data, and works amazingly for those sorts of use cases. For example, log analytics is largely built on top of that. In answer to your question, Databricks is not part of Synapse, but because of the experience that we bring in from technologies like from Azure Data Factory, which becomes the sort of Synapse pipeline experience, it's a separate service, but you can orchestrate it within Synapse as well. But there is a separate Synapse Spark pool. Cool. So hopefully that clarifies what we're talking about. So then the second part is what is the Lakehouse? So this session is about Synapse and the Lakehouse. So hopefully I've given you a quick overview on the first part. But what does the Lakehouse actually mean? This is what I always imagined it was. And the team from Advancing Analytics also often use a similar image. I always think of a peaceful house, something that probably gets built on Grand Designs or whatever, delightful. But let's actually talk about it. What is it aside from marketing? And before I sort of get to that, who's familiar with the Lakehouse architecture? So I will similarly. So read about it. Seems to be the leading vote, which is awesome. And realistically, that's fairly common. There's a very politically incorrect joke that I could make, but a lot of people are talking about a concept doesn't actually mean that everybody's doing or using the concept in production, or even in test cases. So let's just pull apart some of those terms for a second. So the data lake is really an object store with data stored in a hierarchical manner, right? It's just a place to store data, and it's not a traditional table. It's an object store. So you could put CSVs in there, you could put JSON in there, you could put completely unstructured data, you can put semi-structured data like JSON, or structured data like Parquet. So you can kind of put any one of those files in there, and you're generally doing that in a somewhat hierarchical manner or a structured manner. And kind of what that means is that the Lakehouse approach is we've got a data lake. So we've got an object store under the covers, but we've got a logical data warehouse. So we've got those similar things that we're used to with the data warehouse. We've got tables, we've got views. We're enriching that data through different stages, but we're ultimately using a data lake, under the covers of a for example, a Synapse SQL Serverless environment in a Lakehouse architecture. Instead of having, if you're familiar from a SQL Server world, instead of having an MDF file or an LDF file, like a data file and a log file, you've instead actually got just data sitting in the data lake that you're querying over the top of. And that creates a very separate environment where your file storage is quite decoupled from your query engine, and you can therefore interact with that data in the data lake independent of your different query engine. And I think that's where the real advantages and importance come in. There's also sort of two other really important terms within the Lakehouse sort of ecosystem that I think are worth really understanding. So Delta Lake. We've had data lakes. Data lakes are old. Now we're at Delta Lake. A Delta Lake is just the data lake using the Delta format. So, it's just instead of using a Parquet format, instead of using a CSV format, instead of using a JSON format, it's using the Delta format. And some people prefer to call that a Delta Lake. It's not a different service. It's not a different construct. It's ultimately the same approach and everything. It's a file format with certain constraints and additional artifacts with it. It's not it's just important to understand that part. The second part of it is Databricks Delta is sometimes talked about. So, okay, that is a very good question. What is the Delta format? So the Delta format is a extension to the Parquet format that allows you to have some of the advantages that you get with a data warehouse, like for example, updates and inserts. And I'll sort of get into this shortly, but I just want to give you the quick answer while you're asking the question. With some of the advantages still of having a lake. So it uses the Parquet format, which is an open format where it's effectively, a columnar format. It's typed. It's got some of the things we like about data formats and databases without the disadvantages that necessarily always come down. I'll sort of get to probably Fernando, because I think Fernando's question is getting to a broader question, which hopefully I'll resolve by the end. And then we also have Databricks Delta. So there was a previous question about, is Databricks part of Synapse? And it's a service we can interact with within Synapse, but it's not actually a part of Synapse. And it's important to understand that Databricks Delta, so there is the Delta format, but there's also Databricks Delta, and Databricks Delta is a series of proprietary engine capabilities that Databricks has on top of the Delta format. So same name means two very different things, because the Delta Lake and the Delta format is a open format. And multiple tools can use it, whereas Databricks Delta is a series of tools that are proprietary to their engine. So, what does the typical data lake look like? So I'm going to hopefully get to that question as well. The typical format looks relatively similar to what you would think a warehouse process looks like, right? At a very high level. So we've got the source systems. That might be structured sources, that might be unstructured sources, that might be streaming sources, that might be whatever you have. that data being ingested into the bronze layer or the raw layer. You can call these terms whatever you want. Bronze, silver, gold is largely a term that is used within the industry a lot. It's up to you what you call them. I have a personal view that they should not be called bronze, silver, and gold. They should be called like raw, cleansed, and curated. It's a very personal view because I am a person with weird opinions about things because they annoy my sensibilities. But that doesn't actually mean that you should take any credibility in my dislike of calling things bronze, silver, and gold. And for a lot of this presentation, I'm going to call it bronze, silver, gold because it's the naming convention that has won the, is considered standard these days. So you've got a bronze layer. You'll often be landing that data in a couple of different formats. So you might be landing that in Parquet. So that's that typed columnar format. So if you're bringing your data from a SQL Server environment, makes a lot of sense. For example, or potentially makes a lot of sense to move that data into Parquet. You don't want to just be dumping it out into a CSV and running into potential typing problems. I'll discuss in a second why maybe you might want to change that view. But you can also land that data in JSON, CSVs, or whatever. Very often, I actually see customers, even from structured sources, come landing that data in JSON format into the bronze layer. And you might be thinking, well, you just told me that Parquet is nice, it's neat, it's data typed, it's columnar. Why would you put it in a different format? And if you've got source systems that never change their format, never change their schema, Parquet is really nice to work with. It's really easy to work with. But the reality is that every time I've worked in a data engineering environment, the analytics team is usually the last to know that somebody's decided to make a core change to the ERP system, add a whole heap of tables, remove a whole heap of fields that used to exist, change some things from int to like string to varchars or whatever. Like pick your poison, right? They make changes and then they whinge at you at 9 a.m. when the dashboard or report isn't working properly. And so, like one of the great things that landing that data into JSON as opposed to Parquet gives you is the ability to use tools to infer schema, to manage schemas, to say, what is this data this time? And can I validate it against my schema? Or alternatively, can I say, I can't map this data and I need to create a rejected rows process and kick off a business process back to the owners of those systems. And that's a large reason why you will often see at the bronze layer JSON used as opposed to Parquet. You just need to decide which way you want to go. And then what happens is that data sort of moves through a process. And this previously might have been like a staging schema in the data warehouse world or a landing schema in the data warehouse world. And it sort of moves into the silver layer. And from the silver layer, what we generally start to see is that data sitting in Parquet because you're doing some sort of schema management, schema inferencing as you move from from bronze to silver. And you're either putting that in Parquet or Delta. So why Parquet, why Delta? So Parquet files, are just a file. You write them out. And then if you want to change a row in that file, in a particular Parquet file, you have to delete that Parquet file and write it out again. You have to do an edit to that file, which is generally going to be a complete read and a complete write to delete that file. Delta file, like the Delta extension to Parquet, allows you to be doing updates to that. So if you're deduplicating data from your bronze layer to your silver layer, Delta gives you a lot of those capabilities because it supports effectively upserts. Well, inserts are kind of easier, updates are harder. Updates is where the Delta really comes into its own, and that might be, for example, if you've got a sales table where you've had a sale change, it's gone from in process to processed or something. You might want to update that because you're deduplicating that data in silver. And then similar things are sort of going to happen as you move towards the gold layer or the curated layer. The gold layer or the curated layer often look a lot more like we expect in a data warehouse, right? We've got facts, we've got dimensions, because most of our reporting tools and most of our downstream systems are wanting those sorts of things. The interesting thing about the silver layer is often it's a compromise between what are we doing to cleanse it enough that it has meaning and that it's workable, but we're not fully refining it so that it's too refined. And that's often because the silver layer is what's powering, data science projects, just analyst exploration. If you're an analyst, you've certainly been in the or a reporting engineer, like a BI engineer or something. You've probably been into the space where you're like, we don't have data in our current facts and dimensions, so I need to kind of go swimming and find this data and figure out how do we then get it into our facts and dimensions. And that's where the silver layer really comes into it. And so that's the sort of process that we look at a high level, data moving from very raw to something that is refined, curated, and you can call that the bronze, silver, gold. Some customers even go a step further. They have a platinum layer and potentially call that a logical layer. This starts to become where my opinions start to maybe become, or my argument as to why I don't like bronze, silver, gold, platinum becomes a problem, because if you put a fifth layer in there, what do you call it? But most customers generally are between 3 and 4 layers. It's rare that I would see 2 layers. It's rare that I would see 5 layers. So you sort of start to see that sort of process existing. For some customers even, and I don't necessarily think this is the Lakehouse approach, but it is an approach that some customers go, for example, that logical layer might be sitting in a data warehouse or some sort of SQL environment. It's not particularly common. It probably is not technically considered the Lakehouse architecture, but I think most people who are implementing things know that this idea of sort of architecture that you read in a book or more likely read online, and what has to get implemented in reality and to meet business expectations sometimes means that you end up breaking the architectural guidance for the sake of keeping your job and delivering value to the business. Unobtainium, Rohedium, yeah, we could keep going. So what does this actually kind of look like, right? So like I've just talked about moving data between layers, but I didn't tell you how to move data between layers. Like on this slide, there's a lot of jobs being done by these purple lines. It's covering a lot of the difficulties. So what does this look like with Synapse? And so let's kind of break this down a little bit. Everything that I sort of just talked about is independent. You could implement that with AWS, you could implement that with Google, you could implement that with anything you want. It's not particularly Microsoft specific, it's definitely not Synapse specific. This is where we sort of say, okay, how does Synapse actually match up to this architecture? And I want to pull apart some of the differences. So first of all, we see that Synapse Link provides the capability to just land that data directly into to raw. So where you've got Cosmos DB or Dataverse, you can do that which is generally available. Like you can just do that right now. But you can also in public preview, I think we announced yesterday, I don't know, is Azure SQL and SQL Server 2022. So you don't need to have a process that lands that data into raw for you. For those source systems that don't have that process, or can't have that process, or maybe you don't trust a managed data movement service, you can be using Synapse pipelines to do that. And that's a very similar way to the way you would design a pipeline in Azure Data Factory or any ETL tool, right? You're going to take incremental updates from the source system using some sort of like last modified, some sort of watermark table or whatever, and move that into the data lake, copying data from one place to the next. People in the warehousing and the analytics space have been doing that for years and years. So that's the first part. That's like, how do we get that? And you can orchestrate that just with Synapse pipelines. But then I need to orchestrate the rest of the process. And this is where Synapse Pipelines as a data movement tool and an orchestration tool means that you can orchestrate all sorts of different services across this process. You can use whatever floats your boat. And the three main tools that I would see customers using is, first of all, Synapse Spark. Code first environment where you've got a Spark environment that you can execute this data, and you execute Spark workloads, and you can move data from, bronze to silver. So that might be starting to deduplicate the data, starting to join tables where there's logical mappings. You want to get, say, from third normal form to something a little bit more reasonable, like instead of having all these millions of joins, maybe in the cleanse layer, you're just trying to refine it down so it's a little bit more usable, and you don't always have like integers for status fields and that sort of stuff. Similarly, you could use data flows to do that. Low code, no code GUI environment. You can do that sort of mapping. You can also be doing within data flows, for example, even getting to the point of data assertions. So data assertions is to say, this field should be an integer. And if it's suddenly a string, then we need to fail part of this process. We need to fail it for those rows. We need to do something because this is not what we're expecting, and that's going to cause downstream problems. And then the final option you've got is Azure Databricks. Azure Databricks is not really a Synapse service, but because of the capabilities you've got with Synapse Pipelines, you can just orchestrate an Azure Data Factory job. And some people might be saying, well, I've got Synapse Spark, I've got Azure Databricks. Why would I choose one over the other? And that's a complex question. And as someone who now works on the Synapse team, I'm not sure how unbiased I can be in answering it, but I'm going to have a quick crack at it. But take it with a grain of salt. So Azure Databricks provides a whole host of capabilities on top of Spark that you don't necessarily get with Synapse Spark. Synapse Spark has some capabilities that Azure Databricks doesn't have. So for example, being able to talk to Synapse Link is probably one of the big ones. But Azure Databricks is a very mature environment. And it has things like Delta Live tables, which works extremely well. So you need to pick which way you want to go, but it's not necessarily a situation where using one or the other locks you out from either environments, because you're probably going to end up writing all the data into the silver and gold layer in that Delta format, not Databricks Delta format, because when you persist the data in the data lake, you're actually writing it in the Delta format. So you can use all three of these tools. It's rare that I would see someone using all three. What I would generally see, and Paul, let me know if this answers your question. What I would generally see is customers either decide to go with Synapse data flows across the board, right? Particularly teams that are not, not going to be very comfortable with a very code-first way of working, because in both of these technologies, Azure Databricks and Synapse Spark, you're in a code-first environment. You're using languages like Scala. You're using languages like Python. You can use Spark SQL. If you're an MS SQL developer, Spark SQL is all right, it's approachable, but it does do some different things that'll drive you a little bit, will just grind you a little bit. So things like you can't do top 100, you write a limit statement, it works. So I would generally see customers either go down that no code space. They're just like, no, we're not going to get involved in it. We're going to fully go low code, no code. The second option is that I see a scenario where you've got a data engineering team that have coding skills. And they're comfortable with coding. And they might say, we're going to standardize on one of these, either Synapse Spark or Azure Databricks. They're generally going to choose one or the other. The idea of using both those tools simultaneously just adds complexity. And complexity when you're working with people who have to manage that complexity. They have to write jobs to that. They have to think about any of the minor differences between these two technologies. Is just too much mental overhead. So they'll generally pick one, and they might be responsible for going from bronze to silver. or for potentially, productionized models or models that they've accepted as a data engineering team. They might say, we'll do, Spark or Databricks all the way through to gold, like we're responsible for this model being developed. But they will probably also be in a situation where some of the silver to gold happens in data flows, because there's always some business users who want to use data flows. Maybe they've started out off with, Power BI, Power Query, they've got a model, but actually suddenly it's got quite big and, half the business is running on it. And suddenly they need a GUI way to manage this problem, but you've got a core data engineering team that maybe doesn't have the capacity, doesn't have the, the business knowledge or whatever to take that on. So they might end up using Synapse data flows to do that. And so you see this sort of graduation process. And then the third type of customer is just they choose either Spark or Databricks all the way through. And they just standardize completely on that path. At the moment, I would say that for customers who standardize on a code first, so either Synapse, Spark, or Databricks, I would more often see them choose Databricks as the standardized way. That's also, partially because Databricks has been in the market a lot longer, and that means that it's more mature, but also it's got a better community behind it, and that's not necessarily a huge problem. Sorry, what am I trying to say? Like having a huge community behind it is a huge advantage. One, it makes it easier to hire people. It also makes it easier just to get help with things. Like, it sounds silly to say, but sometimes being able to search something and get a really good answer on Stack Overflow as an engineer makes your life so much happier, and you don't end up like going bald trying to solve a problem. I say that as someone who has that particular problem. So that's the sort of key differences. Fernando, yes, the pricing model does differ. I would encourage anybody who's choosing these technologies on a pricing model to POC that, to see whether the pricing assumptions that they're making actually come true. I have seen a lot of customers choose an architecture based on pricing without going through POCs, where the assumptions that underpinned their pricing decisions were way off, and meant that in hindsight, they needed to change direction. And I would always encourage people to do that. I would also always encourage pricing models to take into account the human labor impact that happens. So having actually a data engineer is probably, or data engineers is probably actually going to be where a lot of the cost comes in for this sort of Lakehouse architecture. Is there, I'm going to leave that question to the end. So Ramesh, if I don't get to that, please remind me, because I think this will start to become clearer. And so then the question is, okay, so we've got this data in gold, right? We've got DIMs and facts. How do we serve that out to users? And if we're in the Synapse world, Synapse SQL Serverless is, a great way to serve that. What you have to be aware of with Synapse SQL Serverless is that data is just sitting in the data lake, sitting in Delta files, it's sitting in Parquet files. It could also be sitting in CSV or JSON, but we don't want to go there because those files don't have structures that make querying them very efficient. So Parquet, and by extension Delta, because Delta is an extension of Parquet, is columnar, is data typed, has sort of headers and statistics with row groups, which means that we can actually just have a look at a Parquet file and we can figure out whether we need to actually read a particular row group or something. But it also means we can choose to read only a subset of the columns. So because it's columnar, we don't have to read the whole file. A whole file might be, 10 gigs, but if we only need 2 columns from that Parquet file, we can just read the columnar components for those 2 files, drastically reducing the amount of data that we read. And this works very similar to the way clustered column store indexes work or column store indexes work in any database technology. In SQL Server, you'll probably be familiar with clustered column store indexes. So we can use Synapse SQL Serverless to create views over the top of the data lake. They look, they look like normal views. They can even be external tables. They look normal. They look normal in Power BI. They look normal in SQL Server Management Studio. But ultimately, behind the scenes, they're either views over the top of the data lake using something called Open Row Set, or alternatively, they're external tables. So the data's not sitting in an NDF. It's not sitting in an LDF. It's sitting on a data lake storage, which is effectively a form of remote storage. That works extremely well, so long as you are prepared to accept that there is generally a high performance floor. So that means you might only be asking for 10 rows, but it might take 10 seconds or something. And in a traditional SQL environment, or even in a dedicated SQL pool, we can probably optimize that significantly to reduce that, right? We can put things like covering indexes in that. So you get none of the advantages of like covering indexes or whatever, but you also therefore don't have to like insert into a database. You don't have to think about those sort of constraints. And it's a pure pay per use model. So if you want to run a 1 gig query that's going to suck up 1 gig of data, you can just do that. And you don't have to think about what the infrastructure is. You don't have to think about anything. You hit F5 in SQL Server Management Studio, that SQL query goes back to Azure, and Azure figures out, all right, I've got to get these files from this particular data lake. I've got to do this. I've got to do this join. I've got to blah, 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 blah. And then it's going to return those results to you. So there's a trade-off here between sort of performance, price, manageability. You're sort of at one end of the equation. And that performance flaw, can be a problem. So direct querying this, for example, from Power BI is generally going to be a really bad idea. But the great thing is that we have in-memory tools. So we have obviously Power BI datasets, Power BI's in-memory technology, but also we have the ability to leverage things like Tableau's Hyper Engine. I think they might call that now TDE. It's been a while since I played with Tableau in my defense. Or you've got things like, Click's in-memory engine or whatever. So you can be throwing that data into an engine that is really well optimized to report and address those particular needs. And for other queries, it's potentially not the case that you need that sort of blazing fast performance. Yes, very similar to AWS Athena in terms of querying over the top of the data lake. I would say it works quite reliably. I guess the last time I played with Athena in production was well before I joined Microsoft. So probably 5 years ago. So I'm careful about making that comparison, but I'm also careful that my knowledge of that particular technology or some of the challenges that I found in production are 5 years old. So hopefully you understand what I mean by that. And so then we can query from that data. So what services are we using here? So, and this probably goes to Ramesh's question, right? So we're using Azure Data Lake Gen 2. We're not using Synapse SQL Dedicated, and I am going to come back to that, but you start to see that we're not talking about that. We are using Synapse SQL Serverless. We're using pipelines. We're potentially using data flows. We're potentially using Spark. We might be using Synapse Link, noting that at the moment for GA purposes, it's only Dataverse and Cosmos DB that are generally available. And we're not talking about a data lake, data explorer driven architecture. So that's the sort of where we get to in this sort of world. So, like one of the things that I guess I talked through here is like when to use what technology. So, Synapse SQL Serverless is great as a query technology. You want to query, you want to do a select blah, blah, blah from files sitting in the data lake, works brilliantly. Can I use it as a transformation lake? Like I'm a SQL person. My first exposure to SQL was an Oracle simulator in my uni classes. So that's like my background. I quite like SQL. Can I use Synapse SQL Serverless as a transformation layer? Because I'd kind of like that, you know, just being able to write some insert statements, kind of easy, blah, blah, blah. With a lot of disclaimers, you can use it. And it is quite finicky. I would, though, say I would steer customers strongly against this. There are some MVPs who disagree with me, and for certain use cases, I can understand why they go down that path. I just think the finicky nature of it means that it's not ideal. It doesn't mean that you can leverage all of those, like all of the advantages of, for example, Delta. So you cannot query, for example, from the silver layer, where you might have Parquet, you might have Delta, and use Synapse SQL Serverless to write out a Delta table in gold. You can only write out using Parquet or CSVs from memory. Maybe you can write out in JSON or something, but you can't write out in Delta. So you sort of start to see, I can use it, might not want to. Synapse Spark though, can I, like, what role is that playing? So it's really, you know, playing the role of a transformation engine, merging data together, you know, joining different tables, doing upserts, et cetera, et cetera. So it's playing that transformation layer that we think of as classic ETL in classic ETL scenarios. But it's not really a query technology. And this is one of the areas where I would say that, you know, Synapse Spark and Databricks have extremely different ways of working. I'll come back to Mark's question at the end. So Mark, if I don't get to it at the end, make sure you remind me. So one of the big differences I would say between Azure Databricks and Synapse Spark is that Synapse Spark isn't built as a query engine. It's built as a transformation engine. It's built to, you know, you might query the files in the data lake, but you're then bringing it in to a data frame or something. You're undertaking transformations, and then you're writing those out to somewhere. That probably is going to be data lake store. So we don't see it as much of a query engine, particularly given that we've got Synapse SQL Serverless, the ability to have sort of the power of SQL over the top of the data lake, and the tight integration between Synapse Spark and SQL Serverless mean that you can kind of think of these as the left hand and the right hand. Similarly, data flows is a transformation engine, low code, no code GUI, where you've got to have a source and a sink or a destination, right? For those familiar from SSIS, you'll find many of the principles and many of the concepts the same. You're writing to, you know, you're reading from something, you're writing to something. Databricks, on the other hand, is, I guess, a lot more interesting because Databricks can theoretically straddle all of this equation, particularly with some of the announcements they've had around Databricks SQL Analytics. So the ability to write not MS SQL, but their sort of semi-answerable flavor of SQL against data sitting in the data lake, and they can serve that up. So you can sort of go down this Lakehouse architecture completely on Databricks if you want to, as opposed to leveraging the Synapse components. And I see customers do that, but I guess that's not the point of this talk. So you can do that. Probably doesn't really fit into this this architecture where we're looking at the Lakehouse with Synapse. And Databricks is definitely a transformation engine. And, you know, has that sort of rich transformation engine that you can use to write out to the data lake, and then be using, you know, Databricks itself, as I just mentioned, or, you know, quick technologies like Synapse SQL Serverless to work from a Lakehouse architecture. You can also use Databricks or, you know, Synapse Spark to be writing into technologies like Synapse SQL Dedicated if you wanted to, but I guess that's kind of diverging away from the Lakehouse architecture. And then finally, we've got, you know, Azure Data Lake Storage. Like, what's it doing? Well, it's storing data, and I think this is, you know, really interesting because previously we're used to this idea that the storage technology is the query technology, like one and the same. Like, I store data in SQL Server, but I also query data and transform data SQL Server. So what you're actually seeing here is that we are querying data from data lake, but in the same way that we query data from a C drive. Like, we're not really querying it, we're just reading data from there, and it's certainly not a transformation technology. So you sort of start to see the real splintering of the different components of this architecture and the ability to do things independently of each other. So I guess so far, does that so far make sense? I've got Mark's question. I'm going to try and come back to Ramesh's question as well, because I think both of those will start to become clear. But is everybody with us? It's also a great opportunity for me to take a big drink of water. Cool. It's a shame I don't have a Belgian beer or something. Fortunately, I have some Belgian friends in Dublin who have taught me that my taste in beer prior from Australia was probably not ideal. So how and when the Lakehouse makes sense. So let's talk, we talked about kind of the what, let's talk about the how. So, we really see that the Lakehouse architecture makes a lot of sense in batch data scenarios. And when I say batch data scenarios, I'm talking to anything sort of up to hourly scenarios, because the slowest part of the data lake is generally going to be getting that data in, moving it through those different stages. And I would say this is classic case where Lakehouse makes sense. Sub 1 hour, you start to think about a streaming architecture that might leverage parts of the Lakehouse approach, but that might be much more, a Databricks Lakehouse approach as opposed to leveraging as much the Synapse side. It's also important to understand, scenarios that are streaming where you actually don't have non-real-time reporting. And that's because the slowest part of the data lake is ultimately going to be this part here. At the moment, there will be changes and improvements. That's the slowest part of the process. So if you need data to immediately go into a large Power BI report or something where you can't be using some of the streaming technologies, then you're ultimately going to have to look at alternative ways of working. And sometimes that means that you end up using SQL technology, which can often work quite well for that, or you go down a streaming architecture component where a data lake might form a real key component of it, but you might have to think about how the Lakehouse architecture works. I would say it scales from 10 gigabytes plus. So, I generally find that it works extremely well for even very small data sets, so long as you're making the sort of assumptions that you need to at a small data set. Certainly from, anything at 100 gigs plus works quite well and, doesn't require too much thinking. 10 gigabytes to 100 gigs, you need to be thinking about how much processing are we doing? Are we over processing the data for what that is? And, maybe things like Power BI data marts is where that sort of 10 to 100 gigs starts to work really well. But similarly, you can make the Lakehouse architecture work quite well. I think the final part that and this is, this line here is doing a lot of heavy lifting in this slide. A lot of modernization and rework is going to be required. If you go down the Lakehouse approach, you can't bring your SSIS packages with you. You can't bring your, stored procs that nobody actually understands how they work because they were designed by somebody who used to work here, who left 10 years ago, and then they were modified by somebody, 5 years ago, but still nobody actually understands how it works. And there's like a piece of documentation that like scares everybody. If you're not prepared to undertake modernization of what your potential data stack looks like, assuming you're wanting to migrate from something, then it's not going to be a suitable architecture for you. And I would always say that you need to be at some point prepared to pay down that technical debt, because even if you migrate into a new service that actually can take those old stored procedures and still run them, you still have inherent technical debt that you have to address one way or another. So at some point you've got to do that, but if you're not prepared to do that today, then don't look at the Lakehouse approach. And that, for some customers that I've worked with, means that they've got a system that works on SSIS and traditional SQL Server data warehousing stack, and they might move that to Azure, they might move that to something else, and then they go through a gradual process of modernization. But you can't just adopt the Lakehouse hoping that all of your existing tech will work and that you're not having to pay down that technical debt in order to get there. But at some point you have to pay it down anyway. So, technical debt is a lot like credit card debt. If you're not paying down the principal, you're just going to get killed by the interest charges, because it generally is going to give rise to a whole host of failed pipelines that then mean that your team spends more time diagnosing why the data load didn't happen, and work doesn't get done, and you kind of end up in this pretty disastrous scenario. I am going to come back to that question, but broadly speaking, unfortunately you're on the right track. So Synapse and the Lakehouse approach, this is where we sort of end up. We end up with something that looks a lot like this. This is the sort of broad architecture that we get to, and the modernization process that has to happen to convert things into Synapse Spark code, or Dataflow's code, or Dataflow's GUI. It generates code in the background so that you get those sort of CI/CD benefits that you get, and then or Azure Databricks. So you've got to address that modernization process, and you've got to be mindful that if you need data in a report, in near real time, you have to think about how do you manage this particular part of the problem, and how do you manage the performance components that impacts that has, but also the cost impact that has. So you can, for example, directly query a Synapse SQL Serverless environment from Power BI or from Tableau or something similar. But every time you run a query, you are going to be charged for that, and there's going to be IO and impact associated with that. So you have performance and cost impact there, so you want to be careful. So let's talk about the tips and traps, and then hopefully I'll try and get to, well, I will get to everybody's questions. So first of all, use the right tool for the job. I earlier sort of went through this, like, be careful. So for example, yes, you can use Synapse SQL Serverless to do transformation, but make sure you're aware of the risks of that approach and what's the complexity, pardon me, of that approach going in. Similarly, just figure out what transformation tech makes sense for you, and figure out what makes sense for your team. If you've got a team of people who know Spark, then happy days. You can either go with Synapse Spark or you can go with Databricks. But if you've got a team of people who have never coded, so they've never used Python, they've never used Scala, and you're suddenly saying that we want to build everything on top of Databricks and Spark, then you're going to have to deal with a whole heap of change management. And that means that you're going to have to invest in training. You're going to have to invest in development. You're going to have to develop those skills. That's going to mean that, there's frustration. There is time spent just learning things, figuring things out, doing things the wrong way, doing them the wrong way again, maybe the wrong way again, and then figuring it out, figuring out the right way and that sort of stuff. And so you have to be very careful when choosing which tool to go, that you're taking into account, your data needs, your performance requirements, your cost requirements, but also that people requirement. I would probably almost go so far as to say that if you want to heavily leverage Synapse Spark or Azure Databricks, you have to have somebody with a good bit of Spark experience, either through through a consultancy partner type arrangement, or alternatively hiring somebody in. You need that ability to really develop that capability within your team. If you've got a team that's not coming from a good level of knowledge there. The second part of this, and this generally goes to all modernization strategies, is deliver horizontal use cases. So the biggest mistake I see customers make with adopting a Lakehouse approach, or adopting truthfully in architecture, is they go from their source systems, then they go into raw. Like they do all their source systems into raw, and they're like, great, we got a data lake. But they've burned through 6, 12 months or whatever, and they've got data sitting in a data lake. They don't have better reports. They don't have better business value. The better business value ultimately comes from either having reports, having that data enriched back into a system, having that data be able to power an ML model that means that you can more accurately assess credit risk, or whatever your business does. So focusing on those horizontal use cases is really important, as opposed to sort of trying to look at this in vertical use cases. And the third tip I have is, partitioning matters a bit. And so partitioning, which is conversely part of what I probably should have discussed earlier. I always think about this presentation, whether I should front load this or not, but anyway, I make different decisions every time. Your raw zone. So if we think about the different zones, the bronze, silver, gold, bronze, raw, same thing, is probably going to have a naming convention where these represent individual folders. We've got, system, I don't know, SAP ERP, table name, sales, even though SAP doesn't call it that. Was my first exposure to German. Year 2022 or whatever, month, 05, day 25, and then you might have files coming in on an incremental basis. So it's easy to write. It's easy to copy that data into that data lake because it's partitioned on like last modified date. So that makes sense for a raw zone because you're optimizing to be able to write that data in really easily. You don't want to have to edit anything. You get huge levels of duplication in your data lake, obviously, for this reason. But that's okay. We can resolve that through our different zones. We can address those problems. The question, though, is, do I keep that partitioning and this partitioning? Do I keep that partitioning strategy throughout? No, of course not. One of the big things that differs between these different zones is not just like how refined the data is. That is one of those things, but it's also about what partitioning strategy you've got. So raw, I want to be able to write stuff easily. I just want to dump files in, go from there. At the logical layer, though, I want to be able to read that data in a way that makes sense. And I want to be able to do partition elimination, because if I've got a whole host of different Parquet files sitting in different in different folders, I want to be able to very quickly drill into the one that I want. And I only want to have to drill into that. And so that's where, probably the biggest thing about these zones starts to become thinking about partitioning strategies and how you choose the correct partition strategy. I say it matters a bit because I guarantee you will pick the wrong partitioning strategy for parts of your gold or logical layer, your gold or platinum layer, right? I guarantee you will. Everybody does it. You partition on a certain strategy, on a certain key, because you're like, this key makes sense because I'm pretty sure that's the queries that are going to come in. And then you start to monitor the queries that come in and you go, right, I guess we need to repartition our data lake. Like repartitioning your data lake is not the end of the world. Repartitioning the logical or the curated layer is something that customers will do. And they'll when they first implement the Lakehouse architecture, they'll probably have to do it, within a month or so. And then maybe they'll wait 3 months and they'll have some subtle changes that they're going to make to their partitioning strategy. And you kind of go from there. And obviously repartitioning your data, which means like rewriting it out, reorganizing everything, is a relatively costly endeavor. But generally, if you're deciding to repartition your data, you are doing so because the performance advantages and potentially the cost benefits that those performance advantages use, because often in the cloud, performance is directly related to cost. is worth it. And so accept that you're going to have to occasionally repartition your environment. Don't do it too often, but just accept that a month, maybe 2 months after implementing this, you'll start to realize that maybe you could partition data differently. And so that's just part of the process. It's part of learning how your users and your various tools are leveraging the data lake. And it is what it is. In the same way that you might decide to re-index a SQL environment. You sort of realize, oh, actually, I don't need that field in an index, but I actually do need a different field in an index. Or alternatively, I try and change the different, I create another index to cover certain queries or something like that. You can think of that in a very, very similar way to the way partitions work. Different, technical construct, but conceptually very similar. The fourth trap and the final one is like, you need to test your data. So one of the quite legitimate criticisms, or one of the criticisms of the data lake is I can't have referential integrity in my data lake. Okay. You can't have a lot of things in the data lake that you might be expecting in a SQL environment. And in fact, a lot of traditional data warehouse environments don't support referential integrity in the way that we would necessarily want them to work. And that's about changing the way you think about things. So rather than saying I need referential integrity in my data lake, it's about saying, how do I test that data? So what sorts of referential integrity am I testing for? Am I testing it across all my different systems? Am I testing it across some of my systems? Am I testing it to ensure that, for example, I don't have duplicate surrogate keys in a table that I definitely, in a dimension table where I definitely should not have duplicate surrogate keys? And am I using a referential integrity capability in a database to achieve that? That's actually just about testing your data. And so I always think that data warehouses largely have allowed us to get away without a lot of testing and a lot of without undertaking data tests. And that, in the SQL world, you might be using the framework T-SQL-T. In the Python world, you might be using something like Great Expectations. But in the world that we, in the Synapse world, we have the ability to have data expectations. We have the ability to undertake data tests. And so building that from the get-go means that you can avoid that. It's also a great way to ensure that when a source system has made a change, where the source system owner or the DBA in charge of the source system has told you, no, that row can never have this. Never, ever can it have a 0 in an int field, and then suddenly your ETL process breaks because there is a 0 in the that particular int field, and it causes some sort of downstream problem. So having those tests built in to be able to flag rows or flag problems very early on is something that kind of we always needed to do. It's just that we could kind of muddy our way through with data warehouses. So I actually meant to put that back, but that's okay. So that kind of concludes today's, do I have good references for writing data tests in the data lake? So with data flows, you can use the assert function. With Databricks, there is actually the ability to create expectations with Delta live tables. With Synapse Spark, it becomes a little bit harder to manage. To be honest with you, some people actually end up orchestrating tools like Great Expectations separately to the sort of Synapse environment. But it is an area that I think probably needs more work. And I'm also yet to see some really good write-ups that I would say it's actually on my list of new things to do that. Given we've got a little bit of time, I'm going to take 5 minutes to cover off one additional thing. Sometimes people sort of say to me, how do we make things like Power BI work with this, some sort of in-memory tool? And we've talked through this. We've talked about here's the couple of different ways to interact. Within Power BI, we've got the ability to use Synapse SQL, we've got the ability to leverage Azure Databricks, or we can actually directly connect to Parquet sitting in the data lake. We can't connect to Delta from memory, but that's from memory. So we've got 3 ways to connect to that environment. Generally, I would see most customers going down the Synapse SQL route because it kind of also then becomes easier to write incremental refresh components. But if we look at the sort of different ways to do so, generally most customers are going with import mode. Direct query works, but it has a whole host of problems. And MIM has a whole host of information on its website about this. So I have transition statements here. So you can kind of do it either way if you want to, but incremental refresh comes down to the way you leverage different partitions, right? So if, for example, I have a fact table in my, I've got a fact table that ultimately sits in my gold layer, that I'm probably going to partition that by invoice date because I'm probably going to use incremental refresh on invoice date. I'm not going to use it on top of last modified date because that means that my partitions are not actually going to be mutually exclusive and collectively exhaustive. So this is where the sort of partitioning part intertwines with how you actually query, which I guess is hopefully a quick way to answer a question that maybe somebody had, because normally when I talk about this, somebody ends up asking me. And then you can leverage, Azure Databricks or Synapse SQL. You can't really do that from a direct file access. It just becomes tricky to do, in my experience. So you then go from there. Synapse SQL, I think, is personally easier to work with incremental refresh, but that's my own view. So I think we're going to stop the recording and I'm going to answer some of the questions. But while the recording is stopping, I'm happy to answer one of them because I don't